Okay, a couple more examples here. First off, let's look at a function f of x equals x squared plus 4. And we just want to evaluate this function at different points. So we might be interested in what is f of 1. Now, we don't need a calculator for something like this. We can do this in our head, but let's use it anyway. So I'm doing 1 squared plus 4, and the calculator gives us an answer of 5, so we write down that the answer is 5. And we say, now I want to do f of 3, and we go to our calculator and we say, well, then I'm doing 3 squared plus 4, which is 13, so we go back and we write down our answer is 13. And these we didn't need a calculator for, but maybe something else like what is f of 2.7. With enough time we could probably do that in our head, but if we've got a calculator handy, why not? 2.7 squared plus 4 is 11.29, and so we write down 11.29. And we just keep going in this vein. Anytime we've got a number, we just take it and we square it and we add 4 and we write down the answer. So let's see, we've done 1, 3, 2.7. How about negative 4? And we go to our calculator and we do negative 4 squared plus 4. And we write down our answer is negative 12. And we go to the next question. And we're just trucking along now. And as we get to the next question, we stop and think for a second and we say, wait a minute, x squared has to be a positive number, because if I square something, I'm always going to get a positive number. And then I'm adding 4 to it. So it was a positive number that I added more to. It should be even more positive. How did I get a negative 12? My calculator's broken, because my calculator told me it was negative 12, so there's no way that can possibly be right. Now I give up. But we got to remember that the calculator does exactly what we tell it to do in the order that it is programmed to do it, which is, please excuse my dear Aunt Sally, parentheses, exponent, multiplication, division, addition, subtraction. So if we want negative 4 squared, we can't type into our calculator negative 4 and then hit the squared button. We have to type negative 4 in parentheses and then square it, and then we can add our 4. And as we see here, this was not the correct answer. The correct answer for negative 4 is a positive 20, which without a calculator doing it in our head is exactly what we would have gotten. But if the equation had been more complex and maybe we didn't want to do it in our head quite as easily as this, we want to make sure that we remember, if we are squaring a negative number, put it in parentheses. Not just squaring. Anytime you're applying an exponent, if the number is negative, make sure you put parentheses in there. That's just a reminder on the way you use your calculator here. Okay, question that wasn't on the study guide. Oh, I'm sorry. No, this question is on the study guide. It's a lot like question number 18 or question number 31 on the study guide. We've got a function a times b to the x power. I don't know what a is, I don't know what b is, but we will say that b is a positive number. We're never going to, in these exponential functions, put a negative number under our exponent. We'll always make sure that's a positive. A can be negative, but b never will be. So we don't know much about it other than the fact that when x is 1, the function is 12, and when x is 5, the function is 972. Alright, well, so let's see what that does for us. The fact that x is 1 gives us a 12 tells us that if I do a times b to the 1 power, that equals 12. That doesn't tell me what A is, it doesn't tell me what B is. It just tells me that if I multiply them together, I get 12 for an answer. Maybe A is 1 and B is 12. Maybe A is 12 and B is 1. Maybe A is 4 and B is 3, and so on, and so on, and so on. Okay, so we look at the other piece of information that we've got. When X is 5, the answer should be 972. All right, well, so X is 5, plugged into here, says that A times B to the 5th is equal to 972. Now we have two equations that have two unknowns in them. I don't know A or B, but I have two equations, so I should be able to combine these somehow in order to solve them. When we did at the beginning of the year things like x plus y equals 2 and 3x minus 4y equals 10, if you remember doing those, the strategy was to multiply and then add or subtract to make one of the variables go away. So in this example here, we may have said, I'm going to multiply this top one by 4 and make it 4x plus 4y equals 8. And now if I add up the equations, 7x, 18, the y's go away. And that's the beauty of it, is that we get rid of one of the variables. Well, adding and subtracting isn't going to make one of these variables up here go away, but dividing will. So let's try dividing. If we do A times B to the 5th divided by A times B to the 1st, then that's the same as 972 divided by 12, because A times B to the 5th is 972, A times B to the 1st is 12. Over here, the A's cancel. That's what we were trying to accomplish. Get the one of the letters to disappear, and B to the 5th divided by B to the 1st is B to the 4th. 972 divided by 12, we could probably figure this out, but we'll use a calculator. 972 divided by 12 is 81. And so B to the 4th is 81, which means B must be the 4th root of 81, which is plus or minus 3. But remember that we said B was going to be a positive number, so we're not going to concern ourselves with the negative. B is 3. Then we come back up here and we say, well, now I know B is 3. A times 3 has to equal 12, so A is 4, and that means I now know that the equation here is 4 times 3 to the x. This is a lot like question number 18 and question number 31 in the study guide. One more quick example here. If I've got an equation like this, say this is bacteria, the population of bacteria as time goes on, and the equation is 90 times 100 to the t over 8, and all we want to do is see what these numbers mean. Just explain what the different pieces of this equation are. This 90 out front would be our starting population. We have 90 bacteria, 90 individual bacteria, or maybe we're measuring in millions. Maybe it's 90 million. But this is where we are starting. Then what about this 100 and this 8? What these two, in conjunction with each other, tell us is that every 8 hours, hours because we were told that time is measured in hours, the population is multiplied by 100. If we want to know what it is after a certain time, we just plug that time into this equation and solve it. But I want to make sure we understand that what this means is we're multiplying by 100 every 8 hours. And here's where we started.